What's up, my mathletes? That's right, Musky coming at you, Mr. Muscarella, as we dive into our third and final video of Pythagorean trig identities, where we look at our final trig identity, the one involving tan squared plus 1 equals secant squared. All right, so we've had two Pythagorean identities so far, the mama one, sine squared plus cos squared equals 1, and the papa one, 1 plus cotangent squared equals cosecant squared. And now it's time for the baby one, and that's our third and final identity here involving tangent squared. So we're all the way up down here now in examples 5 and 6. So again, you could take these, tan squared plus 1, and generally we're going to be working with one of those two more than likely when we do our substitution. So let's just kind of review here a little bit. When we take a look at Pythagorean identity number 3, the first example there, number 5, this first term is my linear term, right? And our second term here, minus secant squared, that's our quadratic term. So we need to be familiar with with that language, quadratic term and linear term. Now there's no constants, so we don't have to worry about that because we already have it set equal to 0. From here, what we're going to do is make a substitution. So we look at our linear term, that's in terms of tangent. Now when I look at my Pythagorean identities, none of them are in terms of tangent. They're in tangent squared, but I don't want tangent squared. I need a tangent. So I can't use the tangent squared. I can't use this guy right there as my substitution. I'm going to simply replace secant squared with this tan squared plus 1. So that's what's going to go in for secant squared. So when we do that, really take your time because we've got a minus sign in front of that, right? So we'll have 2 tangent of theta minus, and then put parentheses there because it's then tan squared theta and then plus 1 equals 0. So we'll have this to start out with. Now from here, we'll distribute that negative sign and get rid of it. So we'll have 2 tangent theta minus tan squared theta plus 1 is going to change to minus 1 when we distribute, and that's equal to 0. Now we're going to rewrite this in standard form. We're going to rewrite that in standard form. And when we do that, we're actually going to take everything, because if I notice my quadratic term, this guy right here, that is negative. So there's two ways you can think about that. One is flip the sides of everything, because you would do that just by multiplying everything by a negative 1. Or you could move everything to the other side. Either way, we would end up with the expression tan squared theta, and then 2 tan theta is going to become negative 2 tan theta if we multiply by negative 1 or move it to the other side, and negative 1 will become plus 1, and then that's equal to 0. So that would be, because you always want to have your quadratic term be positive. So whatever your trig function is that's squared, you want that to be positive. From here, holy moly, look at this. We've got another perfect square trinomial, bro. Nice. I like that when that happens. So that'd be tan theta minus 1, and then tan theta minus 1 again, equals 0. And if you're not sure, you could always multiply that out, and you would end up with the resulting tan squared minus 2 tan theta plus 1. But one of the things you want to look at is the term right here, that's negative, your linear term, which means both of these are going to be negative when you're dealing with a perfect square trinomial, as we are today for this example. From here then, that's pretty cool because we were only going to have to solve this once. So make sure you write your tan theta minus 1 equals 0. Be sure to do that. Then you'll have tan theta equals 1. And we're already in terms of tangent, so we're cool. So on the unit circle, where does that happen? In 2 different spots. So tangent theta is going to be 1. So again, on the unit circle, tangent is going to be positive up here. And that's at 45 degrees, or pi over 4. 45 or pi over 4. And then the other spot where that would be the case is 180 degrees away, or at 225 degrees, or 5 pi over 4. So those would be the 2 spots where that would be solutions. Those 2 angles would be solutions to our original equation here. So that's it for example number 5. Now if you think you got it, that's cool. Go ahead and pause the video, then come back, check out example 6 on your own. But for those of you who want to play along with example 6, let's roll. So in example 6, let's take a look at what we got. We've got a tan squared, so that's my quadratic term, or negative tan squared. So that's my quadratic. This guy right here is my linear term, plus 3 secant theta. And then I've got this one little lone guy right there, that's my constant. So those 3 things are what we're going to be working with today. Now, tan squared is my quadratic term, so tan squared is going to be the one that I'll replace. So tan squared is going to get swapped out with this guy. But be careful, because notice we got a little negative sign in front of there, right? So don't be lazy and forget about that spot. So we're going to replace tan squared with secant squared theta minus 1. And then we still have our minus 3. And I'm actually going to start to write that in standard form. So I'm going to move the plus 3 secant theta there, and then the minus 3 next. From here, we'll distribute that negative sign. So, okay, so I'll have negative secant squared theta plus 1 plus 3 secant theta minus 3 equals 0. From here, we're going to combine our constants, all right? So we'll have negative secant squared theta plus 3 secant theta, and then plus 1 and minus 3 give us negative 2 altogether. Now, again, when I look at this, here, let me clean this up so that actually looks like secant, because I know if you guys wrote that, I'd be like, what? I can't tell what it is, so be neat. I want to have this standard form with my quadratic term being positive. And right now, my quadratic term is not positive. It is negative. So that's a problem, right? So we got to fix that. So when we do that, we're going to multiply all the terms by negative 1 to switch sides. So we would now have secant theta, secant squared theta minus 3 secant theta, and then plus 2 equals 0. Now, again, this is straightforward quadratic here to factor, and we would factor that into secant theta minus 2 and secant theta minus 1 equals 0. And again, don't forget the equals 0 on there. So we've got two different options here. So first one, secant theta minus 2 equals 0, which would give me secant of theta equals 2. Now I got to do the reciprocal of that, right? Because we got secant, so that would be cosine of theta. And the reciprocal of 2 is 1/2. Now for my other term here, so I've got secant theta minus 1 equals 0, so that's going to be secant of theta equals 1. Do the reciprocals, so that would be cosine of theta, and the reciprocal of 1 is itself, so that would still be a 1. And where's cosine 1? So again, 1, that's my x-coordinate, so that'd be right here at 0 and 360, but be careful, you know, because 0 is not 360 is not included because of our domain restriction. So they'll just be 0 and 0. And you don't have to write 0 pi, because who writes that? So those would be our two answers, our two values right there on the unit circle that correspond with cosine being 1/2, and our one value on the unit circle that correspond with cosine being 1. All right, so that's it. Now you've seen all three different Pythagorean trig identities. So you'll use these to solve many problems, and I'm sure you'll rock it out like the rock star that you are. Thank you guys for watching. Have a great day, and I'll catch you soon. Peace out.